Good morning, students. Today we are going to see some points regarding these vectors. First of all, we have to understand what is meant by a vector and how we are going to deal with these vectors in our applications or for our subject, or to understand any phenomena, how we are going to use these vectors. First of all, we are measuring so many quantities. Okay, generally we give numbers to those quantities, and we call those quantities as physical quantities. Then, coming to these physical quantities, in some cases we have to tell the direction. Otherwise, it is missing some aspect of that quantity. Suppose if you take a quality, the quality maintained by some shops are better when compared to some shops. To have a better quality, we have to give the direction of the shop where it is. Otherwise, there is no need. Suppose if I ask you to bring a rice of 1 kg, then what you will do? You can go to the town anywhere and you can buy it. But if I want a good quality, I have to give a specific direction for that one. That is, to have some clarity, I am going to have some directions to these things. Okay, the quantities that need direction are called as vector quantities. Okay, and they are entirely different from just our numerical addition. Okay, if we want the addition of these type, then we have to understand how we are going to add these directions. That's why while dealing with these quantities, generally we represent a vector with a arrow mark, where the length of arrow indicates the magnitude or the number, and the direction of arrowhead, okay, it indicates the direction of the quantity. Okay, this is how we are going to represent a vector. Okay, in printed books they are going to use bold letters, okay, to indicate a vector. While writing in hand, we keep a small bar on that one. Okay, now if we represent two vectors like this, then how to add these two vectors? First, we take one of the vector, first vector, then at the head of the first vector, we take the tail of the second vector. Same pattern. Then, from the tail of first vector to the head of second vector, we turn this one like this. Okay, starting from tail of first vector and ending at head of second vector. This is how we are going to add these vectors. It forms a triangle. This is called as triangle of vectors. Okay, and it can be understood by making use of this type of constructing a parallelogram. If they are taken as adjacent sides of a parallelogram, then the diagonal gives the resultant of those two vectors. Then, while writing like this, we are freely moving these two vectors like this, these positions. So, in general, all these types of vectors are called as free vectors, where they are placed parallel in the same direction, and our intention is we can move these vectors freely. That is, by representing a vector, we choose a convenient place to represent a vector. Okay, these types of vectors are called as free vectors. In some cases, we do not have such type of chances. Okay, we have to give the specific direction for that one, or at the specific line of that vector only we have to represent. Those vectors are called as localized vectors. That is, we cannot freely move those types of vectors. That's why they are called as localized vectors. We are going to come across such types of situations also. Okay. Then this is how we are going to add these vectors. Okay. Then, if we consider consider this vector as we are telling that a direction is associated with that one. Generally, to understand anything, we go to coordinate system where there are three axes: x-axis, y-axis, and z-axis. Okay. Then, while writing these vectors like this in the axis, we first give a unit vector in a specific direction. That is, along x-axis we call that one as I cap, along y direction or y-axis we call that one as j cap, along z direction k cap. Okay, these are unit vectors along those directions. Then any vector can be represented like this. Along x means along I direction there are x number of units, along z y number of units, along k there are z number of units. Then if you square this one, we get b square is equal to x square plus y square plus z square. Or if a vector makes an angle theta with a given axis, then we can divide or resolve. Resolution means understanding a vector in some specific directions, which are in general they are mutually perpendicular to each other, the three directions. Okay, then if we divide them or if we resolve this vector into known three directions, that is x, y, z, or along I cap, along j cap, along k cap, then the each numerical value along the direction is called as component of that one. Suppose if we take a simple case in two dimensions, if this vector makes an angle theta, we call this one as Vx, we call this one as Vy, or we can get it as I times Vx plus j times Vy, or Vx, if it makes an angle theta with this axis, we call this one as, we get from this triangle, we can get this one as cos theta is equal to adjacent side the hypotenuse. Then this becomes, then the component containing theta is p cos theta. Okay, if we take this theta here, it becomes p cos theta. The component containing theta is cos component. Okay, you have to remember well. Okay, this is how we are going to resolve a vector. And generally, while adding, we take same types of vectors while adding or subtraction. Subtraction means, see, if we are subtracting b from a, then we have to just reverse this direction. It is a special case of addition. Okay, and while performing this addition or subtraction, we have to deal with same type of quantities. Okay, then coming to multiplication, the multiplication of vectors gives a different vector. Suppose if we multiply a vector with a simply scalar or a number, then we are going to have the same direction for that vector, but the magnitude is increased by the number with which we are multiplying that one. Okay, the magnitude is going to be multiplied. Okay, and there are two types of, apart from that one, there are two types of vector multiplication. If we multiply two vectors, we are going to get either a vector or a scalar. If we get a vector, it is called as vector multiplication or cross product or vector product. If we get a scalar, scalar product or dot product. And as a simple case, for I dot I, this is equal to 1, I cross j equal to k. The remaining I dot j becomes 0, then I cross I becomes 0 like that. See here. If a vector is given by a bar is equal to axi plus ayj plus azk and b bar is equal to bxi plus byj plus bzk, then we simply write a bar dot b bar is equal to this one. We get. If we expand this one dot a bar dot b bar, then ax into bx I dot 1, I dot 0, then remaining terms become 0. Then next one. Ay bx j dot I 0, ay by j dot j1, is ay bz j dot k 0. Then az bx k dot I 0, az by k dot j 0, az bz k dot k 1. We are going to get this. Okay. Then in a similar way, if we write this a bar and b bar, and if we simplify that term, we can simply remember this formula for this a bar plus b bar. I j ax ay az bx by bz. This is mod of I j k ax ay az bx by bz. Or these products are like written like this: a dot b is equal to mod a into mod b cos theta. Okay. Then a bar plus b bar mod a to mod b sin theta to n. Here, as it is associated with a direction, we have to tell the direction of this one. Then, to understand the direction, suppose if we are having two vectors like this, and if I am multiplying these two things, if I want to tell the direction of these, the resultant vector, which is a multiplication of these two vectors, then how to understand that one? That is, suppose if I am having this a bar like this and b bar like this. Okay. From this one I am writing a mod b sin theta. Okay. In this case, it is simply a value. There is no problem with this direction. But to understand this direction, suppose if I see these two vectors from the same plane, that is from the bottom side or from that side or from that side or from this side, these two vectors, I cannot clearly understand the magnitude of this one and the magnitude of this one. If I am seeing from this position, I am seeing a line and I am seeing a line, but I do not understand how they are exactly present. If I am seeing from this direction, same from this direction, one, the next one is a dot. If I see from that direction, again we are going to get. If I see from that direction, for A, that is I am seeing from this one. For A, I am just seeing a point. I don't know whether it is a line or not, but we can have a clear picture of that one if we see in a perpendicular direction, from this side or from back side. Okay, then we can easily understand that. That's why, see, we give the direction that is normal to this plane, normal to the plane. Okay. In one case, we are getting a scalar product. In the second case, we are getting a vector product. Okay. This is called as vector product. We get a vector, where n cap is a vector, unit vector along a direction perpendicular to plane containing a bar and b bar. Then, to find the angle between two vectors, we make use of this one. It is a number, a dot b, mod a number, mod b number. Then theta is equal to cos inverse of a dot b by mod a mod b. Okay, we can find angle from this one, not from this one, because again there is a direction associated with this one, a complication. That's why to find the angle between two vectors, we make use of this one. Okay, these are some just basic fundamentals regarding these vectors. Based on these things, we can go to the further chapters.